In this video, I'm going to walk you through a simple web-based tool for calculating relative risks and odds ratios, two important measures in epidemiological studies. Now, the goal of this web app is to not only calculate these quantities for you, but also to give you some intuition behind each of those quantities as to what they represent, how they're computed, and how to interpret them. So let me walk you through the layout of this web app to begin with. The heart of this web app is a 2x2 table that allows you to choose from a drop-down menu of different study designs. Since the case control study allows us only to calculate the odds ratio, it will be treated differently than, say, these others that the cohort study, a randomized trial, and a cross-sectional study that will additionally allow us to calculate relative risks. I'll demonstrate an example using the cohort study design. This table now gives us the columns that correspond to the disease and no disease group, and the rows that correspond to the exposed and unexposed. If you have a table that you would like to recreate from, say, a textbook or a journal article, you can modify the order of these columns by using this drop-down menu and just changing it to match the structure of the table that you're using. So if I wanted no disease in the first column and disease in the second column, I can make that change. Similarly, I can edit these names from cancer and healthy to whichever disease group I'm interested in. Let's use an example about cardiovascular disease. So I just type in CVD and no CVD. Similarly, maybe my exposure of interest in this study is hypertension. If the table I'm using reverses the rows for exposed and unexposed, I can easily modify that here by simply choosing unexposed for row 1 and so on. And now what I'll do is I'll just enter the values for my table, and notice that the inner cells are editable and the row and column totals are updated automatically as values are provided. Now, this setup matches a table that I have in a textbook that walks me through some examples of calculating relative risk and odds ratios. So now with it set up this way, I can follow the example in the textbook exactly. By default, the odds ratio is highlighted, but for the cohort study, I can obtain a relative risk. So I'll click on that. On the right-hand side, it gives me the calculation of the relative risk. And beneath that, it gives me a formula for how it obtained that quantity. And it reminds the user that this is simply the risk of the exposed divided by the risk of the unexposed, and further digs into how that risk is calculated. Just the proportion of those in the exposed group with the disease over the proportion of those in the unexposed group with the disease. Below that, I have an interpretation for the relative risk. At first, it tells me what the overall finding is between the exposed and unexposed groups. This is followed by some additional measures that can be useful, such as the risk difference and the population attributable risk, and then just the prevalence, the proportion of cardiovascular disease among each of the exposure groups, and an overall prevalence of disease. Over on the left-hand side, I have some more information about these absolute risk measures. It digs into the idea of what a risk difference is, additional terms that may be used for a risk difference, such as attributable risk, shows me how that is calculated, and gives me a strong interpretive sentence. The population attributable risk section also gives me similar information, where it gives me the formula for calculating the PAR, calculates that value for me, and then gives me an interpretation. Also, there's a tooltip here at the bottom about cohort studies. This will be similar for cohort studies, randomized trial designs, and cross-sectional studies. Let's look at the odds ratio that can be calculated for each of those studies as well. Notice this gives you the opportunity to recognize very quickly that the relative risk that we calculated for that data set, 3.37, is different from an odds ratio, 4.02. This similarly gives me a couple of formulas for calculating the odds ratio. The first is the cross product formula. Another way of calculating the odds ratio is that of the events to non-events. These are updated dynamically as you change values in this table. At the bottom, we have a tooltip telling us about cohort studies. Again, that doesn't change unless we change the study design in the drop-down menu. One thing that has changed is now, instead of having information about risk difference and the PAR, now I have some interesting properties being explored about the odds ratio. In particular, the invariance of the odds ratio. And the other tooltip here is referred to as the symmetry of the odds ratio. If I change my study design to a case control study, notice that the relative risk is no longer an option, since it's not appropriate to calculate the prevalence or the risk from a case control study. Now, there may be times where the calculated odds ratio or relative risk is less than 1, and that becomes a little trickier to interpret. So there's a toggle button up here at the very top that says inverse metrics. And what that will do is it will just take 1 over the odds ratio and give you an updated version of these formulas and interpretations that are consistent with that change. That concludes an introduction to this epidemiological calculator. Hopefully you find it useful and informative.